Hello everyone, my name is Sara Cotrina, and me and my friends Gabriel Ramirez and Maria Paula Giron, we are a group of scientists that are investigating and searching more about the wonders of the universe. One of them is the black hole. So let's join us to this great adventure that is Until There Was Nothing.
Oh, hello. I'm the scientific of the University of Harvard. So, in the class today, I want to explain the singularity concept. What is singularity? Singularity is the term that we use in physics for the elements or the things that we don't know. That, for instance, the equations or that we know doesn't work, like the black holes. The black holes have like the uniqueness that we want, like we can call singularity, because only we know when we are inside of them the real properties of that black hole, because it's unlimited. We only have like theories like it's unlimited, or like it's faster than the light and absorb all the things that are around him, and is the collision of suns. Is only like theories, and in the moment when we introduce a human and can like go out, we like can like change the name of singularity to other term that we can use in physics, because singularity is the unknown that we can like explain with our equations and theories.
Now we are going to explain the gravitational fields. First of all, we have to understand that we can classify the forces into groups. The first one is the contact forces, and the other one is the distance forces. The gravitational interaction is one of the distance forces. The concept field is used to explain how all the forces interact from a distance, and is defined as a region of the space in which is designed to each point a value. Now, a forces field is a region that can have alterations in its properties because of a body that generates distance interaction. The gravitational fields show how works the gravity from a distance. If we have an object with m mass, this object going to generate a gravitational field around it and going to affect the trajectory of another object. So, if we put an object of mass n, it's going to receive a gravitational force that's going to be made by the field of the first object. However, if another object of m mass approximates to the object with the same mass, their movements going to be disrupted by the gravity force, and according to the relativity theory, the time will be also affected by these forces, distorting it and having as a result the black holes. Those phenomena has a very strong gravitational field. The gravitational fields were first understood as a theoretical nature with the Newton theory, which said that was a vectorial field. We can define this field with two magnitudes: the gravitational field intensity and the gravitational potential. The intensity is the same that the gravity acceleration. Is represented with a g and with vectors field. That means with lines that have sense and direction. Commonly is defined as the force per unit of mass that a particle will experiment in presence of a distribution of mass. Is expressed in newtons by kilograms. The gravitational potential is an scalar magnitude that is measured in joules per kilograms, and is defined as the work needed by a unit of mass to transport a body in a constant velocity from infinite to a determinate point in the gravitational point. The most common example of a gravitational field is our solar system. Now we have the concept waves. What is a wave? A wave is known as the propagation of the energy, not the mass, in the space caused by a disturbance of any of its physical characteristics. For example, the pressure, density, electric or magnetic field. These phenomena can be produced in both in an empty space or in an area with matter. The waves are produced as a consequence of oscillations or vibrations of the matter that propagate through the time. We can talk about different waves of light, sound, etc. Each one with different physical properties and frequency depending on the medium through are propagated and how much energy they transport. We can identify different types of waves. The first one are the mechanical waves. They need a physical medium to can be transported, a liquid, solid or gaseous medium, for example. Also need the temperature and temperature. The most common example is a sound wave that commonly are transported by the water or the air. The other one is the electromagnetic wave that doesn't need a medium to can be spread in a correct way. An example is the light that can propagate in empty.
Okay, my other concept is spaghettization. It refers when a black hole attracts an object and the massive force of the gravity makes the atom of the object move in the way that more and more in the center of the density. Like can like in a straight line because of that force. For that, the simply way we don't have like a weight for resist to that force. We have is like our bodies enlarge and move according to the center of the black hole.
Okay, as my classmate already explained some topics, now I'm going to explain the light behavior. I'm going to start with the reflection. This is a phenomenon that occurs where the light bounces when it reaches a surface and it bounces it. The reflection have three types: regular reflection, diffuse reflection, and also mixed reflection. The regular reflection is when the surface is flat. The diffuse reflection is when the surface is round. And the mixed one is when we have both of them. Okay, now I'm going to talk about refraction, that also is divided in three. This is another phenomenon that occurs in light where it have an interaction between light and matter. It's because some materials allow that the light pass through them, such glass and water. We have regular refraction, also we have diffuse refraction and mixed refraction. Okay, as I said, there were three types. The regular one is when the refracted rays are on the same plane. The diffuse one is when the transmission medium is irregular. We can say as an example that the glass is translucent. And the mixed one is when both of them occur. Okay, and for last we have absorption. That is a phenomenon that have all material types. It belongs to the property of these to absorb in a partial or total way the radiations that became from light.